So this last video in my series on differentiation is going to be looking at some final points of notation and also your second derivative. So let's start off with our notation. So up until now we've been looking at functions where you have y on the left hand side and then a function in x on the right hand side. So y equals x cubed, say. And your first derivative has been dy by dx. In other words, we've been looking at how y changes with respect to x. In this case, it's going to be y equals 3x squared. Now, if I change my variables over, and now I have, say, y on the left-hand side and t on the right-hand side, my first derivative here would be expressed dy by dt. So in this case, we're saying, how does my y change with respect to our t? In this case, you're just going to differentiate the right-hand side with respect to t. So applying the same rules, you're going to bring this 3 to the front, decrease your power by 1, 3t squared, like that. And then you can extend this idea across to any combinations of letters and symbols. So I don't know, you might have dr, you might have r expressed in terms of theta, so r equals, I don't know, 7 theta squared. In this case, your first derivative would be, you notice here I've got y on the left hand side, y is on the top here, I've got r on the left hand side here, I'm going to have r on the top here, and that's going to be differentiated with respect to theta. Okay, always respect your theta. Bring this 2 to the front, gives me 14 here. 14 theta, decrease the power on my theta by 1, so this 2 now becomes a 1. Don't really need to write 1 up there, it's just going to be 14 theta. So here, clearly you can see, not particularly difficult here, just something to look out for. If your derivatives are expressed like this, where you have different letters, different symbols, just try and compare it to your base case where you have y expressed in terms of x, and obviously you'd have dy by dx there. You just need to replace your letters as appropriate. Okay, moving on to your second derivative now. And at AS level, you look at the technique of working out the second derivative, but you don't necessarily learn the applications of that second derivative. So, second derivative, if I have this, y equals 2x cubed minus 7x plus 6, you know your first derivative, dy by dx, I'm just going to differentiate the right-hand side with respect to x as per usual. So bring that 3 to the front, combines with my 2, gives me 6x, decreasing that power by 1. That 3 now becomes a 2, minus 7. Your second derivative, if I were to differentiate this right-hand side again with respect to x, that will give me my second derivative. This is denoted by notation like this. It's called d2y by dx squared. So that's little 2 up the top there, and this is again a superscript 2 up there. And again, applying the same rules, just differentiating right hand side with respect to x, hence your second derivative. I'm deriving it twice with respect to x. Combining my 2 with my 6 there gives me 12x, decreasing my 2 by 1 here, give me a power of 1 up here. I don't need to write that. This minus 7 disappears. So that's your first example using your y and x notation, your dy by dx notation there. Second example we're going to look at is using your function notation. So function notation, the original function is going to be this one here, 3x cubed minus 6x squared plus 6x. So your first derivative here, you know that it's f dash of x or f prime of x. Differentiating this right hand side here with respect to x, bring this 3 to the front, gives me 9x squared minus, bring this 2 to the front here, combines with my 6 to give me 12x, decreases power, I have a 1 over here, don't need to write that, plus 6. And now your second derivative here, if you're using function notation, is going to be f double dash of x. Okay, so that denotes your second derivative. Again, I'm just going to differentiate this right hand side here with respect to x. My 2 combines with my 9 to give me 18x. 2 becomes a 1, don't need to write that, minus 12. So here we've looked at two different pieces of notation to denote our second derivative. Either if you're using function notation, you're going to use f double dash of x, as was the case here, whereas if you're using your y's and your x's, you're going to be using your d2y by dx squared notation there. Thanks very much for watching, and don't forget to subscribe for more tutoring videos. Remember that full notes and other resources are available on my tutoring website at idktuition.com. And if you'd like me to cover anything in particular, please leave me a message in the comments below or on Twitter at TomDavies32.